Hi, previously we have talked about interaction paradigm. Now we are going to talk about interaction frameworks and interaction styles. In this presentation, we are going to discuss frameworks for understanding interaction, how do we cope with complexity in interaction, and what are the different interaction styles. What is a framework? Framework is basically a structure that provides a context for conceptualizing something. We can use these frameworks to structure a design process or help us identify problematic areas within a design or help us conceptualize the problem space as a whole. What constitutes a problem space. We have two types of understanding or conceptualizing an interaction. We have what we call the execution, evaluation, action cycle. It concentrates on the user's view of the interaction, does not consider the system beyond the interface. And the interaction frameworks includes the system and the way it communicates with the user by the way of the interface. So here, the system and the user are both important. The execution, evaluation, action cycle structure is like that. We begin by setting our goal, saying this is our goal. Then we look at how do we execute an action in the real world to get our goal, to get to our goal. The world is the world is the place where we execute and manipulate objects, and evaluation is where we evaluate if we have already accomplished our set goal. There are 7 stages for the execution evaluation cycle. The first stage is establish your goal, and then we come to the execution part. The execution part, we form the intention to get to our goal. We specify what actions are needed, and then we execute those actions. Once those actions are executed, we move to the evaluation. Evaluation, we perceive the world state. Did we do what we wanted to do? We interpret our perception. We get a feedback, first of all, the perceive, and then we interpret the perception, and then we evaluate this interpretation to see that we have actually accomplished our goal. For example, if I want to delete text, the goal is to delete text. I get the intention, I have the intention, I look for the way. The way is to go through a menu, through the edit menu, and then the delete after I select. So I go and do that, I execute, and then I get a feedback from the system. I perceive the state, the new state. By looking at it, I will see that the text was deleted. I interpret what I have perceived. I don't see the text anymore, so it must have been deleted. And I evaluate that my goal was accomplished or not. Now, in the execution, evaluation, action cycles, we have what we call the gulf of execution. Gulf of execution is the distance between the mental representation held in our mind for a certain task and the physical components and the states of the system. Deleting, we envision deleting as just using a rubber to delete. So this is our mental representation. But actually in the system, we need to select what we want to delete and then go to the edit menu and the delete. So we have to, for example, if we want to save, the goal is to save a file. Our intention is to use the file menu, and then the action is to click. Okay, while in our mental state, saving is putting it in somewhere, taking the file and putting it somewhere safe. Okay. The gulf of evaluation, which is the distance between how we perceive things and the results. Okay, given a particular interface design, how easily can we determine the function of the device, or what actions are possible, or how do we map our intention to, how easy can we map our intention to a physical action or move, how easily can we perform the action, how can we determine that the system is in the desired state, and how can we determine that the mapping from the system to the interpretation, and how can we determine where or what the system state is in. Second type is the interaction framework. In this, we have 4 parameters: the system, which uses its core language. If it's a computer, it uses computing language. The user uses its natural language or task language. How do we perform tasks? And then we have series of inputs and outputs. Inputs to perform tasks and outputs to perceive results. So if we put it in the context of execution and evaluation, in the execution, we perform the articulation, we formulate the goal, and then we perform. So we use the input language or the task language to perform what we need, and this is translated into the core language that the system understands. Now the system manifests the results and it presents it to us, and then by observation we see what the result is. So in this case, we have a continuous execution and evaluation, and using a series of inputs and outputs between the user and the system. How do we cope with complexity? How do we perceive things? How do we see things and understand the functionality of things? How do we understand or perceive what we need to do? We have 4 types to cope with complexities. We have what we call mental models, we have mapping, we have semantic and articulatory distance, and we have what we call affordances. Let's start with the mental models. Mental model is a cognitive representation of something. For example, if I know when I drive a car that if I turn the steering right, it turns right. If I turn the steering left, it turns left. Also, doing it with a bicycle, I know that if I turn the steering rod right, the bike turns right, and if I turn it left, it turns left. So in both cases, this is my perception or cognitive perception. But in the bicycle, the object is transparent, so they expose their function. I can see the actual movement. But with cars, for example, it's opaque. I don't know how it works on the inside. Also, a mental model might help us understand interaction. For example, some novice internet users might only know how to get to sites using a search engine, because this is the only thing that they saw to access. So if it is close enough, if the model is close enough to the actual functioning of the system, then we can use it without difficulty. Mental models are usually unscientific. They are guesswork and approximations. They are usually partial. They don't see all the details. They are unstable. They have, they are not concrete formulations, but they evolve and adapt. They are inconsistent. They might differ from one person to the other. they are inconsistent and personal. Mapping. Concept of mapping describes how we make connections between things. If we look at this example, this is a gas oven. Now these are the buttons that turn turns these flames on. Now this is an arbitrary mapping. We don't know if this button is for this one or for this one. We can optimize this by, for example, or improve it by dividing these two buttons for these two flames and these two buttons for these two flame sources. But still, this one, we don't know if this one is for the first one and this one, or for the second one. The natural mapping is the position of the controls mimics the position of the flame sources. So I know that this one is for this one is for this one is for this one, and this one is for this one. So we use the natural mapping whenever it's possible. We have also what we call semantic and articulatory distance. Semantic distance is the distance between what people want to do and what the interface model does. And the articulatory distance is the distance or between the physical appearance of the interface element and what it actually does. For example, for the articulatory distance, if I see an almost closed door used for exit, I can tie it with the concept of exit. But if I have an arrow that points somewhere, it's not obvious what its relation with exit is. So I can say that the articulatory distance between the physical appearance of the almost closed door and the exit is less than the articulatory distance between the arrow and the exit. Affordance. Affordance is what can we intuitively understand from an interface. For example, steering wheel affords turning. A doorbell affords pushing. A doorbell is there, so it affords pushing. These connections allow us to make predictions about what actions are needed to create a usable model of this interface. طبعا, of course, the affordance differs from one person to another. The perception of affordance fosters usability. The affordance a user may need must be present. For example, here we have username and password in a two text fields, and then the text fields to fill in the username and the password. So, somebody might add the username here and the password here. Others might add the username here and the password here. It depends on the affordance of people. So this is a case of affordance confusion, where certain aspects of an object does not work in the way that we assume they should. This should be a label, but we have used a text box, so we should have used a label, because this affords entering data, while what we need is to show this message, the username. What are the interaction styles? We have different interaction styles. We have command line, we have menu-based, form fill-ins, question and answers, direct manipulations, metaphors, web navigation, three-dimensional environments, zoomable interfaces, and natural languages. I want to go over those briefly. Okay, command line, we use the command line to enter commands. With this, we need to know what the commands are. We need to know what the commands are and how to use the commands with different variations and different parameters. Okay. The articulatory distance is large because we are presented with only a command prompt, no indication of the functionality. We have to have memorized the functionality, and this is what used the way it used to be with DOS. If you wanted to copy, you needed to know the copy command. If you wanted to create a directory, you needed to know the make directory command. If you needed to format, you needed to format the hard disk. If you needed to move the file, you need to move the file. You need to know the move command, and so on and so on. Menu-based interface, it promotes recognition as opposed to recalling. So you recognize, for example, that this is a file menu, it deals with files, edit menu, it deals with edit, and so on. So you need to know the concept, and then you can move around and get to the functionalities of the system. Form fill-ins presents screens of information that you fill in. You have to pay attention to details like putting related data in one area. You can have single scrolling screens or multiple linked pages. You need to know where you are. You need to be able to go back and forth. You need to know what formats to use, and so on, so forth. Questions and answers. You need to provide questions, leave place for entering answers, and moving from one step to another. Direct manipulation.